Hi guys, so we're going to do this extra review pack. You can find a copy of this in the Google Classroom where you're finding this video. All right, so I'm going to graph the first one. The y-intercept is 8 and it's got a slope of -1. You can also use your graphing calculator to help assist you. Okay. So now I'm going to graph the second one that has a y-intercept of 5 and a slope of 1/2. So up 1, right 2. And you're looking for the point of intersection that's known as the solution set, and it appears to be 2, 6. So I'm just going to double check that. Yes, that works there. Yes, that works there. So that's good. So remember, they might just ask for x, so x would equal 2. They might just ask for y, so y would equal 6. But the ordered pair or the solution set is 2, 6. Remember that this point would have to make both equations true because a system is connected by the word and. Solve algebraically. So when I'm solving algebraically, I basically have two choices: the elimination method, where you use additive inverses, or substitution, where you take an expression and substitute it for another. Since these are both in standard form, I'm going to use elimination. I'm going to eliminate the y's by multiplying the bottom equation, or the second equation, by -2. I'm leaving the top equation as it is because I already have a 4y, which is going to match up nicely with the -4y, which I am now creating by multiplying by -2. This is similar to the distributive property. It's not the distributive property, though. It's the multiplication property of equality, but it has that principle of making sure you hit every term. And that's -8, so I'm going to divide by a -1. Remember, if you do not see a number in front of a variable, that coefficient that's missing is always a 1. And in this case, since there's a negative sign, it's a -1. And that gives me x equals 8. Now, sometimes finding just the x would be enough, but most of the time we want the actual solution set. So I'm going to substitute that back in to figure out what y is. So I get 4y equals -8 by subtracting the 24 from both sides. Dividing by 4, I get y equals -2. So I have 8, -2. And I'm just going to do a little bit of mental math to make sure that works. So 24 minus 8, that's good. -4, yep, this is good. And you can always use your calculator to double check as well. Okay, so solve algebraically. I could use elimination. That would work well if I multiplied the top by, say, a -2 or the top by, say, a -5. But I'm going to do substitution just to show you another method. So I'm going to solve this for y, and I would get y equals -x plus 8 because I'm moving the 8 to the other side, therefore I have to use an inverse. Okay, so now I'm going to take this expression and replace the y with it. So now I'm going to create a single equation with only one variable, which is sort of like my first goal. Okay, distributive property. Combining the like terms. The opposite of adding is subtracting. The opposite of multiplying is dividing. And I get x equals 2. I'm going to go here. So that would be -2 plus 8, which equals 6. Y equals 6. So I have what I believe is correct, 2, 6. 2 plus 6 is 8, so that works. 2 times 2 is 4. 5 times 6 is 30. 34, that works. So this is good. You can use mental math to check. You can use substitution to check. You could use your graphing calculator. Okay. So a theater has 200 seats. The tickets are $10 per adult and $8 per child. They would like to raise at least $2,000, right? A system of inequalities. Okay, so I'm going to use A for adult and C for child. So adult tickets plus children's tickets has to be less than or equal to 200 because I cannot sell more tickets than seats. Now I'm going to deal with the money. It's $10 per adult, it's $8 per child, and I want to make at least $2,000. Okay. If half the tickets were sold to children, so half of assuming they sell out would be 100. So I'm going to say that there's 100 children's tickets. So if I have 100 children's, I have 100 adults. So 100 adults, 100 children. Okay. So that would make the first one true because 100 plus 100 is less than or equal to 200. And that is actually why I chose that. But it's really more about the money because that's what it says. Will they make enough money? So if I do 10 times 100 plus 8 times 100, will that be more than $2,000? No, it won't because that's 1,000 and that's 800. And I can tell already that $1,800 is not enough money. Oops. So I'm going to say no. And usually it would say something like justify or explain. So the rationale would be like, okay, $1,800 is not more than or even equal to 2,000. It's not enough money. So they have to sell more adult tickets. You know, maybe it's 120. I don't know, but we could graph it and find out. Okay. Oh, here's graphing. All right, so I'm actually going to be a little weird and I'm going to graph the second one first because it's ready for me. So I've got +4 and I got a -2. Sometimes I just do the first one that's easier just to get it done. And here we go. Oh no, it's got to be a dotted line, so I have to undo that a little bit. Back I go. Oh, look at that. That's a dotted line. I wonder if that would work. It is working. Look at that. All right, so dotted line. Dotted line because there is no equal bar underneath the less than. And now I'm going to color down. So I'm going to try to make this match nice. This may have been a poor choice, but all right. So less than is always lower or smaller. And when I make that decision, I'm looking at the y-axis. So I was actually looking at the +4 when I made that decision. So that's why I decided to color the +3, the +2 numbers that are lower. Okay, so back to a pen. All right, so I have to solve this for y. So I'm going to start by subtracting the 2x. So that gives me 4y is greater than or equal to -2x plus 12. Now I'm dividing by 4. So that's y is greater than or equal to -1/2 x plus 3. Now, I divided into a negative number, but not by a negative number, so you don't change that symbol. Okay, so +3 is right here. And it's down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. I'm going to go a little bit in the other direction to give me some more points. Okay, there is an equal bar, so I'm going to draw a solid line. And now it's greater than, so I'm going to shade above. I'm going to do that in yellow. Oh, okay, so you can see that where it's kind of turning like an orange color. That's the double shade. Okay, now as far as labeling goes, this double shade would get the solution set magic S. And then remember the yellow was this one. And the purple was the second one, which I did first, but that's the purple. There we go. Okay, so now if they ask for a point in the solution set, it would be anything on the solid line from, say, around 1 to the left and anything in the double shade, nothing on the dotted line. Okay, that would be included. Oh, that's all. All right, so you would also suggest perhaps doing some Delta Math review, and you could also relook this over, look over your review sheet, and remember that you can do question 13 on your own ahead of time. If you have any questions, you can email me. Have a great night.